Hi and welcome to the Maths Experience tutorial video with DCU University Dublin. In this video we'll take a look at modulus inequalities, differentiation and implicit differentiation. So we'll start off with the modulus inequality question. We're given the equation the modulus of 3 over t minus 4 is less than or equal to 2, and we have to solve for t. And remember, with modulus signs we have to be careful because we have to consider both the positive and the negative real values that will satisfy the equation. So to get around this, what we'll do is we'll break the equation up into two different parts. Firstly, we'll take a look at the positive value of 3 over t minus 4, and secondly then we'll take a look at the negative value of it. And we'll do this by multiplying 3 over t minus 4 by plus 1 to get the positive value, and then to get the negative value we multiply 3 over t minus 4 by minus 1, and we get minus 3 over t plus 4. Right, so let's take a look at the positive value part of the question first. So what we want to do is we want to isolate t. So we'll bring the variable t to the left hand side, and we'll bring all the integers to the right hand side. So that means here that we need to bring minus 4 across to the other side of the inequality sign, which changes it to plus 4. So we're left with 3 over t is less than or equal to 6. Now there's a bit of a booby trap here. What most people would be inclined to do in this situation is to multiply across by t, but because we don't know whether t is positive or negative, we can't do this, because if it was negative it would change the direction of the inequality sign. So to get around this, we multiply both sides by t squared, because we know that t squared is always a positive number. Any number squared is always positive. So once we multiply across by t squared, we're left with 3t is less than or equal to 6t squared. We then bring the 6t squared across to get 3t minus 6t squared is less than or equal to 0. And then, because it's always nice to have a positive number on the highest power, which is t squared here, we multiply across by minus 1. This will change the minus 6t squared to a plus 6t squared, but remember also it'll change the direction of the inequality sign. So we then have 6t squared minus 3t is greater than or equal to 0. We then divide across by 3, and we get 2t squared minus t is greater than or equal to 0. Remember, dividing 0 by 3 will just give you 0 again. And then we take t out as a factor of 2t squared minus t, and we get t into 2t minus 1 is greater than or equal to 0. We then put both these factors equal to 0 and solve for t to get the two roots. So when we put t equal to 0 and solve for t, we just get t equals 0, so that's one root. And then we put 2t minus 1 equal to 0, and when we solve for t there, we get t equals a half, so that's another root. So our two roots are t equals 0 and t equals a half. And we will then graph this, and remember when we graph it that it's u-shaped because t squared is positive, so the graph will be u-shaped. So here we have the graph of 2t squared minus t is greater than or equal to 0. And what we're looking for here is when the graph is greater than or equal to 0, so basically when it is above or on the x-axis. And we can see that when t is less than or equal to 0, and when t is greater than or equal to a half, the graph comes above the x-axis. So that gives us the solution that t is less than or equal to 0 and t is greater than or equal to a half. We now go back and we take the negative value part of the question and we solve that for t. So here we have minus 3 over t plus 4 is less than or equal to 2, and again we want to isolate t by bringing everything with variable t to the left hand side and all the integers to the right hand side. So the plus 4 we have here in minus 3 over t plus 4, we bring it across to the other side and it becomes minus 4. So that leaves us with minus 3 over t is less than or equal to 2 minus 4, which is just minus 2. Now again we can see here that there's once again a booby trapped. Some people might multiply across by t here, but again we don't know whether it's positive or negative. So to get around this, we multiply by t squared, and we're left with minus 3t is less than or equal to minus 2t squared. We then bring the minus 2t squared across and we get 2t squared minus 3t is less than or equal to 0. We take out t as a factor and we get t into 2t minus 3 is less than or equal to 0. So like we did with the positive value part of the question, we put the two factors equal to 0, and we get t equals to 0, that's one root, and then we put 2t minus 3 equal to 0. When we solve that for t, we get t equals 3 over 2. So that's another root. So our two roots are t equals 0 and t equals 3 over 2. And remember again that this graph is u-shaped because t squared is positive. So here we have the graph of 2t squared minus 3t is less than or equal to 0. And basically to see when it's less than or equal to 0, we check to see when the graph falls below the x-axis. And we can see that when t is greater than or equal to 0 and when t is less than or equal to 3 over 2, that's when it falls below the x-axis or lies on the x-axis. So that leaves us with the solution t is greater than or equal to 0 and t is less than or equal to 3 over 2. And finally then we'll take our two answers, the answer we had for the positive value part of the question and the answer we had for the negative value part of the question, and we'll combine them and get a final answer. So to make this easier, we've illustrated the number line here in red, ranging from, you can see it goes from 0 up to 3 over 2. So remember the answer that we got for the positive value part of the question was that t was less than or equal to 0 and t was greater than or equal to a half. And this is represented here with the green line. And for the negative value part of the question, remember we had t being greater than or equal to 0 and t being less than or equal to 3 over 2. And we've represented that here with the blue line. So basically we're looking for when the green line and the blue line overlap. And we can see that when t is greater than or equal to a half and when it's less than or equal to 3 over 2, the two lines overlap. So this question looks quite scary, but it's actually not too bad if you follow the simple steps. We're told that p of t equals minus 1.7t cubed plus 72t squared plus 7,200t plus 80,000. That's the population of a city t years after 1950. And we're asked what was the population growth rate of the city in 1990. So you have to ask yourself, what are we being asked here? We're being asked for the growth rate of the city, which refers to rates of change. Growth rate is rates of change. And rates of change means differentiation. And just a reminder of the basic differentiation rule. If you were to differentiate 3t to the power of 3, the 3 would come down to multiply by the 3, and the power 3 would be reduced by 1. So 3t to the power of 3 goes to 3 multiplied by 3 by t to the power of 2, which gives you 9t squared. And when we differentiate a constant, that's any number without a variable in it, such as 500 minus 2, a half, when we differentiate any of those numbers, we're left with 0. Right, so again, this equation looks quite scary, but if you're just neat and follow the simple steps, it's not too bad. So we're told that p of t equals minus 1.7t cubed plus 72t squared plus 7200t plus 80,000. We bring the 3 down to multiply it by the minus 1.7, and we get minus 3 multiplied by 1.7t squared. Then in 72t squared we'll bring the 2 down and multiply it by the 72 to get 2 by 72t. Remember the t squared has been reduced to t to the power of 1. The 7200t is essentially 7200t to the power of 1. So the 1 comes down and multiplies by the 7200. The t is reduced to t to the power of 0, which is 1. So that just leaves us with 7200. Then finally the 80,000 is a constant. So remember, no matter what the constant is, no matter how big or how small, we're always left with 0. So that gives us our new equation, which is p dash t equals minus 5.1t squared plus 144t plus 7,200. And notice how the powers have decreased after we have differentiated. Okay, well the second thing we need to figure out is what value we use for t. We are told that t is the number of years after 1950. Since we're being asked to work out the growth rate in 1990, That's 40 years after 1950, so t is equal to 40. So then what we do next is very simple. We take our 40 for t and we sub it in to our equation everywhere we see t. So we get p of 40 equals minus 5.140 squared plus 144 by 40 plus 7,200, and this will give us the population growth for the city for 1990. And when we work that out on our calculator, we get that the p of 40 equals 4,800, which means that the city grew by 4,800 people in 1990. And that's the end of the question. Okay, so our final question is an implicit differentiation question. Again, this looks very difficult, but if you are neat in your work and follow the simple steps, it's actually pretty easy. So the question says, use implicit differentiation to find dy dx where 4xy cubed plus x by cos of y equals 2x. So the simple steps that I spoke of regarding implicit differentiation are as follows. Firstly, we differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. Then we collect the terms with dy dx on one side of the equation, and then we solve out for dy dx. In this question we have two products on the left hand side, so we'll use the product rule to solve them. So because this is a little bit convoluted and could get a little messy, we'll look at them separately. So first of all, we're going to take a look at 4xy cubed and solve that using the product rule. Now remember, the product rule can be found in your maths log tables. So using the product rule, we will put u equal to 4x and we'll put v equal to y cubed. Then to differentiate u equals 4x, u becomes du dx, and 4x, which is 4x to the power of 1, just becomes 4 because the 1 comes down to multiply by the 4 and the power of 1 is reduced to 0, so x to the power of 0 is 1. So we end up with du dx equals 4. For v equals y cubed, you'll notice we have no x in that, but we're differentiating with respect to x. So the v becomes dv dx, the y cubed becomes 3y squared because the 3 is brought down in front of the y and the power of 3 is reduced by 1 to 2. But you have to multiply that by dy dx because remember, we're differentiating with respect to x. So that's 4xy cubed sorted. So now we focus on x multiplied by cos of y. Again, we use the product rule. X is substituted in for u and cos of y is v. So if we differentiate u, we get du dx, and when we differentiate x, which is x to the power of 1, remember, the 1 will come down, which becomes 1, and x is x to the power of 1, which reduces to x to the power of 0, which is 1. So we're just left with 1 multiplied by 1, which is 1. Then to concentrate on v equals cos of y, the v becomes dv dx because we're differentiating with respect to x, and the cos of y becomes minus sin y dy dx. You'll find that in your maths tables that cos differentiates to minus sin. So then we're using the product rule, which I said you can find in your maths log tables. And the product rule states that dy dx equals u by dv dx plus v by du dx, and we'll sub in our two equations. So as we said, if u is equal to x, du dx equals 1. If for v we have cos of y, our dv dx is equal minus sin y dy dx. And subbing these into our product rule, we get dy dx equals x multiplied by minus sin y dy dx plus cos of y multiplied by 1. And when we multiply out these brackets, we get dy dx equals minus x by sin of y dy dx plus cos of y. So we originally had 4xy cubed plus x multiplied by cos of y equals 2x. What we now have is 12xy squared dy dx plus 4y cubed plus minus x multiplied by sin y by dy dx plus cos of y is equal to 2. Remember, the 2x was differentiated to 2 because x is to the power of 1. That comes down to multiply by the 2 and reduces the power on the x to 0, which just makes the x become 1. We're now on track to find dy dx. So the next step is to take everything with dy dx and move it to the left hand side and put everything else on the right hand side. So our new equation is 12xy squared dy dx minus x by sine y by dy dx equals 2 minus 4y cubed minus cos of y. We then take out dy dx as a common factor, and we get dy dx multiplied by 12xy squared minus x by sine y equals 2 minus 4y cubed minus cos of y. And then we just divide both sides by 12xy squared minus x by sine y, and finally we get dy dx equals 2 minus 4y cubed minus cos of y over 12xy squared minus x by sine of y. And that's our answer. Thank you for watching.